Now this question is going to require a calculator from me, just because of the numbers being so weird. It's not necessary. You can do it without one, especially because the t values are nicer to the eye than the coefficients of the p polynomial. So let's try it out and you'll see what I'm talking about. So we're asking, first of all, the average rate of change of this function from 1992 to 2002. We're told that this function describes the population of a city t years after 1992. So at 1992, t equals 0, because no years have passed. And at 2002, t equals to 10. So we're going to calculate the average rate of change by doing p of 10 minus p of 0 over 10 minus 0. That's the average rate of change from 0 to 10. And basically we just plug those in. And because because 10 is such a nice number to cube and to square, you could definitely do that without a calculator. You could definitely plug in 1,000 times that. So 1,000 times minus 0.26, you just move the decimal place 3 times. And then plus 100 times 105, so 105 with 2 zeros. And then, let me move this over there. Seven, 769 with a 0 plus 70,000. You subtract that, so all of that is just p of 10. You subtract that by p of 0. P of 0 is very easy to calculate because t is 0, so all of that equals to 0. So that's 70,000, which means those two are going to cancel out. I'm going to divide that by 10. So that's what I'll plug into my calculator. I'll do a minus 263 plus a 105 with 2 zeros. It's not right. 10. Let me erase that. Two zeros. There you go. And then plus a 7769 with a 0, and then the 70,000s. That's actually a 7,000 what I wrote, but just erase that. So my notes are correct. Those two cancel. Anyway, so I get the result. And I divide that, all of that, by 0. By 10, excuse me. So I just move one decimal place to the left. So 8792.7 people per year. So the city is gaining about 8,793 people a year. Okay? So that's the average rate of change. Now that's easy. The calculator used for this was okay. For B though, this gets a little bit more difficult because we have to derive the function first. On B, we're asked what's the growth rate at 1996 when t equals 4. So we're not given an interval of time. We're asked for the rate of change at an exact moment. So what does that tell us? First, we have to find the derivative. That's what the rate of change is at an exact moment. So that requires us to use the power rule. So that's a minus 3 times a 0.26. Well, 3 times a minus 0.26 to be more exact. Times t squared. Plus, and then a 2 times 105 t. And then plus a 7769. And then the 70,000, when you derive that goes away. And then you plug that in. P prime of 4 is going to be, plug in 4 into this equation. So I use my calculator here on the left to do that. So that's 3 times a negative 0.26 times a 4 squared and that plus 2 times 105 times 4 plus 7769. So that will be, we're not rounding, so we're just getting the exact answer. That's 8596.52 people per year. So that's at that exact year, not an interval. That is the rate of change. It does make sense that this is close, but it didn't have to be. The polynomial could be a little uglier in the terms that, in the sense that, the shape that it has between 0 and 10, whatever that is, just make it so that the secant here is close enough for the tangent to the tangent at 4. So this here is the slope of the tangent at 4. This here is the slope at the secant from 0 to 10. They're close enough, so it does make sense, even though it didn't have to be that case in general.